Here's another example. In November 2004, the Family Credit Counseling Service commissioned a financial stress survey in which 1,590 consumers with credit card debts were asked about physical symptoms that they attributed to stress from their debts. The most frequent complaint, mentioned by 50.8% of these consumers, was that debt-related stress sometimes kept them awake at night. What's the point estimate for the corresponding population proportion? Well, the point estimate is going to be the sample percentage, and since 50.8% of our sample says that debt-related stress sometimes kept them awake at night, our point estimate is 50.8%, or 0.508. Now we'll construct a 95% confidence interval for the proportion of all consumers who are sometimes kept awake by stress, as well as finding our margin of error. So we see in our picture, our 95% confidence interval has 0.025 worth of area in each tail. So using Desmos and normal distribution and inverse CDF, or your graphing calculator, second VARS choice 3, we get a z-score of 1.96. So to calculate our confidence interval, p hat plus or minus z times the square root of p hat times q hat divided by n gives us a confidence interval of 0.4835 to 0.5325, or in other words, our population percentage, all Americans, or the percent of all Americans that are kept awake by stress, is somewhere between 48.4% and 53.3%. Our margin of error is 0.0246, because that is the value that was added and subtracted to our point estimate. Here's our second example. It is said that happy and healthy workers are efficient and productive. The company that manufactures exercising machines wanted to know the percentage of large companies that provide on-site health club facilities. A sample of 240 such companies showed that 96 of them provide such facilities. So notice that there's no mean or standard deviation mentioned. There is a sample size, 240. There's not a percentage though, but we do know how many of our sample have those kinds of facilities. So our point estimate is something we will have to calculate. We're going to have to take 96 divided by 240 to get our 0.4, or 40%. Now we can construct a 97% confidence interval for the percentage of all companies that provide these kinds of facilities, as well as finding our margin of error. So we start with our picture. 97% confidence interval means we have 3% left over to be split evenly in the tails. So using our 0.015 and either Desmos or our graphing calculator, we find a z-score of 2.17. Our confidence interval then is our point estimate plus or minus our margin of error. So 0.4 plus or minus 2.17 times the square root of 0.4 times 0.6 divided by 240 gives us a margin of error of 0.0686 and a confidence interval from 0.3314 to 0.4686. In other words, the percentage of all companies that offer those types of facilities is somewhere between 33.1% and 46.9%, with a margin of error of 0.0686, or a margin of error of 6.9%.